If you haven't already, go to the developer.fermyon.com, and if you click on the Spin project, you'll see the Get Started section here, and that's where you'll find the installation instructions. So go ahead and install Spin there if you haven't already. So what we're going to do today is create a new application using templates. We'll talk about templates a little bit later on. So we type here Spin New, and we're going to be using the HTTP Rust template. And then when we hit enter here, it prompts us for the name of the application. So we'll call this Testing Spin Watch. Also allows you to put in a description. For now, we're just going to hit enter here and just accept the defaults. Okay, so now that we've got the application set up using the template, now inside the spin.toml file is some default watch configuration. So there's like some same default watching out of the box, which is to watch all of the source files, all of the Rust files, I should say, in the source directory, as well as the cargo.toml file. And the other thing that it watches by default is also the testing_spin_watch Wasm file up here, and that's under the component section. Now we can also watch individual files, like user-defined files. We'll come back to that in just a minute. For now, let's just have a look at this operation out of the box. So before Spin Watch came along, we would generally do a spin build, and following that, we would do a spin up, which would launch the application. Now we can combine the two of those and do a spin build -- up, and that would do the build and deploy the application for us on localhost on port 3000. But with watch, all we need to do is type spin watch, and it will actually do both of those things in that order. So build first and then serve the site after that. In addition, of course, watch configured files. There's a few other options that we'll cover in a second. We can skip the build, and we can also clear the screen. We can change the time interval between the watcher actually taking action on changes. Let's start off with changing the source file. Okay, so we go into the lib.rs, we've got a hello Fermyon output. If we change that, add a few exclamation points, and we just hit save, what we'll see is that the application has been rebuilt and is also redeployed on localhost at port 3000 as well. So if we refresh on the client side, we see the exclamation points come through there. Okay, so what we're going to do now is create a new file, and inside that we're going to put a value that is likely to change. So this is a datestamp file, and we've created a directory called changing files, and in that we'll see this timestamp.txt file. So this is to essentially demonstrate static file serving. These could be images, these could be any sort of files that are served statically to the client. In the application manifest, what we can do under the component section is create a new array in here, which lists the files to watch. So in this case, we have this changing files directory that we've just created. So changing files /timestamp.txt now makes that file path watched by the spin watch feature, and any changes to that file will not do a rebuild, but it will do a redeploy, essentially just reserving updated static content. So there's nothing else we need to do other than just add in that file. So if we do a standard spin watch, and we go now into Visual Studio Code and change the timestamp. So let's change the year to 2023 from 2022, click save, and that's reserved. So it's not rebuilt, the application, we just have the new static content served to the client side. So the watch feature will watch this WebAssembly binary here, and any changes to that file will cause the application to redeploy. And in some cases, you might want your integrated development environment to actually take care of your builds. Like say you're under heavy development and you're changing the source code, you might just have a rebuild happening in your IDE. And in this case, we can go here and look for this skip build option in the watch feature. And if we do that, essentially what happens is the application will run, and as we edit our code in the IDE, and the IDE rebuilds and creates a new WebAssembly executable, we will see that the spin watch feature just goes ahead and redeploys a fresh version of the application each time the WebAssembly executable changes. So let's call this Hello Fermyon compile, and we click save, and we'll see nothing actually happens here because we're using the skip build, so it's not actually watching the source file anymore. However, if we go to a different terminal for demonstration purposes, we can actually just manually run a cargo build command in a different directory to simulate the IDE doing that. So essentially it's an independent build of the source code that's happening outside of the spin framework. So in here, grab a new terminal, and we're inside the application directory. We'll manually go ahead and do the cargo build to that same Wasm 32 Aussie target. And the build's finished, and as we can see, as soon as that finishes, the spin framework will actually redeploy a fresh version of the application, and we can see that the Hello Fermyon compile. So that's based solely on that watching of the WebAssembly executable file. One of the other options of the spin watch feature is the debounce. Now this is essentially the timeout between detecting change and re-executing. It's set in milliseconds, and the sane default is set to 100 milliseconds. This is just a default to make sure that the watch feature doesn't over-service the application, but you can change this with the minus debounce. So we can make that recompile and deploy in half the time by just making that 50 milliseconds. So as you can see there, we've launched the application. We go ahead and update the source code, and as soon as we hit save, within a 50 millisecond time frame, we'll get a rebuild and redeploy. Now, of course, you could make this longer if you wanted to, for whatever reason. Just do whatever's best for your application. Let's do an example where instead of 50 milliseconds, we'll push out the debounce value to, say, 5 seconds instead. Output of 5 seconds. Okay, and then we'll restart this and give it the new debounce value. So we'll go 5,000 milliseconds, which is equal to 5 seconds, and now we're watching again. Okay, so pop back over, make a change, and we watch, and 5 seconds later we see that the debounce has worked. So when you're running spin build and spin up and spin watch, the terminal essentially has a history of every time you rebuild, reran, and every watch that you ran. So with the clear, we can actually clear the screen before each run. We can do this simply by launching the application with the minus clear option. So we'll change the output here to Hello Fermyon clear. And we can see that as soon as we save, we get a rebuild and redeploy, but if we scroll up, we see no history. It's just simply that last run. Now, if you have any issues, any warnings or errors in your build, they will still show, but all of the historical ones going back in time are gone because it essentially refreshes the screen. So we're not seeing prior run. Okay, so that's about it for the spin watch feature for this video. Also be sure to go ahead and visit the Fermyon developer home. So at developer.fermyon.com, you'll see Fermyon Cloud, Spin, and also Bartholomew, the CMS that's actually running the documentation site and the Fermyon.com website. As shown before, we have the install instructions, and in addition to that, we have tools, things like managing templates. So if you wanted to know a bit more about how to manage templates on your application, also managing plugins. So for example, how to upgrade plugins and so on. Another handy section to check out is the command line interface reference. So in here you'll see the spin watch that we've covered today. There's a handy table of contents down the right hand side of all of the pages in the docs, so you can find what you're looking for fairly easily. The Contributing to Docs page has a run-through on how to pretty much do everything to contribute to the Fermyon documentation, with the end result being a pull request that we can merge. And it would be great to see some contribution to the documentation. If there's anything that you'd like to improve on or change, you can go ahead and do that, create a pull request, and we'll review that on this end, and that'd be greatly appreciated. Okay, so that's about it for now. Thanks so much for watching, and we'll see you next month.